Yeah, welcome to the first lecture of the course Data Structures. So in this lecture, we'll be discussing a brief introduction to data structures, and also I'll be introducing you to the concept of pointers because whatever the programs that we are going to discuss throughout the course, it involves pointers. So at first itself, I would like to discuss pointers. Fine. So let us start with the definition of data structure. How can we define data structure? So this is one of the way to define a data structure. Data structure is the mechanism of organizing and storing the data properly and establishing the relationship between data stored. Okay, whenever required, these data can be searched, retrieved, sorted, or we can perform various other operations without much effort. Okay, so mainly why we need data structure. So we need data structure because we want to perform typically these operations. So these are the typical operations which is normally required in any human activity: searching, retrieving information, sorting, okay, or some other operation like uh, mm, deleting some item, okay. So these are the typical operations that we want to do on on any human activity. Maybe it may be a list of students. From the list of students list, I may want to identify, I may want to search like how many students got A grade for a given course. Okay, that is called searching. Or I want to retrieve some information like how many students got marks between this range, between 40 to 60, between 60 to 70. Or sometimes we may want to sort based on the marks, sort based on the name, or sort based on the roll number. Okay, this is student data. Or you can take us to supermarket data. In supermarket data, there may be hundreds of items. You may want to search whether a particular item, say Britannia biscuit, is it available or not. If it is available, how much quantity is available. Okay, so or you take a railway data. Maybe the list of trains and its timing will be available, and the starting location and the starting point and the destination location will be available. And then based on the, for example, based on the source and the destination, we may want to identify in a given day how many trains are running. Okay, or and after identifying if there are many trains, then we may want to sort it based on time. Okay, so like that, there is innumerable examples. You can keep on thinking. Okay, but if you but depending on the type of the application, we may have to use different data structure so that these information can be searched, retrieved, or sorted in an effective way without much effort. Okay, so that is the core purpose of data structures, right? I think it's clear. Fine. So now let us try to understand some of the advantages of data structures. So data structures allows us to store data in a, what do you call, in a planned manner so that it can be retrieved and placed in a proper and a planned way. So basically it is organizing the data in an effective way so that the data can be handled, or whatever the operation we want to do, that can be performed in an efficient way. Okay, so when you write the program also, you should have the proper knowledge of the appropriate data structure. So it is not that every program can be written using any data structure. No, of course you can write any program using any data structure, but the complexity of the program may increase if you don't select the right data structure. Okay, so that is the point. So basically identifying the right data structure simplifies the job of the programmer also. The programmer can write a short and an effective program. So what is a program? So in terms of data structures, we can say that a program is something like this. A program is nothing but a combination of algorithm and data structure. Okay. So we know that program is nothing but the set of instructions. The set of instructions is set of instructions are derived from the algorithm, which is nothing but the step-by-step procedure to solve the program, and and also it includes data structure. We use some data structure. You may use arrays, or you may use stack, or you may use queues, or linked list, or any data structure. So choosing a proper data structure is very much important for a programmer. So the programmer should ensure that he is choosing the right data structure so that the program will be simple and easy to use. And the data structure selected, whatever the data structure the programmer is selecting, it should reflect the real relationship that exists between the data in the real world. Okay, so in the real world, whatever the relationship that exists between the data, that should be reflected in the chosen data structure. Even if it is not reflecting 100 percentage, to a major extent it should be reflecting, so that this data structure will help to solve the given problem in an effective way. Okay, and data structure should provide these features. It should allow us to access, store, sort, search data in a convenient way. Because in any application you want to do that, like how I told already, if you take a student data, or if you take a railway reservation data, or if you take a supermarket data, or if you take a employee payroll data, anywhere we want to perform these operations. Okay, these are the typical operations which we perform on any data. So the data structure should provide the possibility or the feasibility to perform such operations. Fine. Now let us go to the advantages of data structures. What are the advantages of data structure? Okay. So, so data structure will help to for the efficient storage of data in the storage device. If you are not using the proper data structure, then it may use the whatever the data we want to store. It may take huge spaces. But if you use the appropriate correct data structure, then the storage device also will be used in an effective way by occupying less amount of memory space. Okay, and it provides convenience while retrieving the data from the storage device. And also, if the right data structure is used, the data can be retrieved easily from the storage device without much effort. Okay, and it provides effective and efficient processing of small as well as large amount of data. So when you choose the correct data structure, the processing will also be effective. And choosing the correct data structure helps the programmer by saving lot of time, or or it reduces the processing time. Okay, the operations such as storage, retrieval, or processing of data, the time involved for these typical tasks can be reduced to a larger extent by choosing the right data structure. And the manipulation of large amount of data can be carried out easily with the use of good data structure approach. Large amount of data can be manipulated easily and effectively by choosing the correct data structure. Fine. And most of the well organized data structures like arrays, stacks, queues, graph, trees, linked list, they have well built and pre planned approach for storage, retrieval, manipulation, deletion, etc. Okay, so I mean these data structures are defined already. It is defined how what are the operations or that can be performed in these data structures and how it can be performed. So so obviously it improves the effectiveness or efficiency of handling the data. Okay, right. So the programmer can completely rely on these data structures and its uh, usage because these are well tested time and again. So data structures can also that the data structure usage can also encourage reusability in long run. So reusability means the existing data structure can be used for something else. For example, already if you are maintaining a student record by using some data structure, and if that student details is required for some other application, then already you have implemented in some data structure. You can directly use that. You need not re-implement. So that is called as reusability. So one data structure which you have created for one purpose can be reused for some other application. Fine. So this is the introduction about the data structures. So we have defined the data structures, and we have understood what is the role of the data structure and what are the advantages of data structures. Now let us move on to pointers. So what is a pointer? So pointer is a concept which is available in C language and in C++. So basically pointers are used to access the memory locations. Basically, pointers are used to access the memory location. So this is how we can define a pointer. A pointer is a variable whose value is the address of another variable. A pointer is a variable whose value is the address of another variable. Uh, What do, so what do you understand by that? A pointer is a variable whose value is the address of another variable. Okay. Say for example, I am declaring a variable something like this: int a. I'm declaring int a. Okay. So what does it mean? A is a variable of type integer. Okay. So if I say that a is equal to 10, when I say a is equal to 10, what happens? A is a variable and some memory will be allocated for a. So this a is the name of the variable. That's all. A is just a label. A is a label to this location, but this location will have some address. So let us assume that address is 2000. The address of this location is what? 2000. And what is the value of a? 10. So 10 will be stored here. Okay, fine. So this is with respect to a. Now again see the definition. Pointer is a variable whose value is the address of another variable. So pointer is a variable and the value of that variable will be the address of another variable. Now say that I am declaring another variable here, that is a pointer variable, int star p. Okay, int star p. So what is star p? P is a variable, p is a pointer variable which can point to an integer. What is p? P is a pointer variable which can point to an integer, right? P is a pointer variable which can point to an integer. It can point only to an integer. It means that it can hold the address of only an integer. It can only hold the address of an integer. Okay. So now P is also a variable, but it is not a normal variable. It is a pointer variable. P will also have an address. Say its address is 6000. But now P is not going to store an ordinary value. Rather, P is going to store the address of some other variable. Okay, currently, and it can only hold the address of an integer variable, not a character variable or a float variable. Currently, P is not pointing anywhere because P is not assigned to anything. Say here I am adding another instruction, something like this. P is equal to ampersand A. Here ampersand refers address of. Okay. Ampersand refers address of. This ampersand, it refers to address of. Wherever ampersand comes, you should read as address of. So what does it mean? P is equal to address of A. What is the address of A? 2000. So P will have 2000. So P will have 2000. Okay. So it means that, but 2000 is not a value. Here 2000 is not an integer value. P, it's an address. It means that P is pointing to this address 2000. And what that address 2000 contains? A. Okay. So now whenever I say P, it refers to the address where it is pointing. Which address it is pointing? It is pointing to 2000. Okay, it is pointing to the address 2000. Whenever I say star P, whenever I say star P, it refers to the value at P. What is P? P is 2000. P is 2000. Whenever you say P, it is 2000. That is the address that is contained in P, that is 2000. So star P means value at this address. What is the value at this address? 10. The value at this address is 10. Okay. So this is how pointer works. So this is the brief introduction to the pointer. Uh, Let us continue with the slide. Okay. So with pointers, we use two operators. One is called as, so these two are the operators. One is ampersand, which is called as the address operator. We can say it as address or address of operator. The other one is the star. The star is called as a dereferencing or indirection operator. Star is called as the dereferencing or indirection operator. So ampersand refers to the address, some address, okay. Whereas star, it is called as, then it is here the star refers to the dereferencing or indirection operator, okay. Fine. So this is similar to an example which I just now discussed. There are two variables. I is a variable of type integer, whereas pi is a pointer. pi is a pointer to an integer. pi is a pointer to an integer. Now we are saying pi is equal to ampersand I. It means that pi is pointing to the address of I. So I is something, okay. I is something. Maybe I's address is 2000, okay. And but I is an integer. pi is a pointer. pi is a pointer, and we have said pi is equal to address of I. Address of I is what? 2000, okay. 2000. Then then there are two ways to assign value to I. If I want to assign value to I, you can directly assign I equal to 10. So then 10 will be stored here. But there is another way to assign I as 10, that is star pi, because star pi refers what? Value at this address. So value at this address is what? It refers to this location. So star pi equal to 10 also, it will assign 10 to this location, okay. So this is what this concept says. Fine. And this, see, the ampersand operator has only one use. Ampersand always refers to, always means address of. Ampersand always means address of, okay. Address of. Whereas star has two purposes. Whereas the operator star, actually it is star, but we call it as indirection operator. The indirection operator has two purposes. One is it is used to declare a pointer. While for declaring the pointer also we use star. Okay. So here int star p means it, here the star does not refers to value at. Okay, here star does not refers to value at. Here star refers that p is a pointer. P is a pointer to an integer. Character star C refers that C is a pointer to an character. Double star D means that D is a pointer to a double. Okay, so here the star operator is used to mean that these are used to declare pointers. Okay, but there is another usage of star. There is another usage of star that can be understood by this example. Here you can see int star p. It means that p is a pointer to an integer. Then int k equal to 10. That is, k is a variable which is assigned with the value 10. Then p is equal to ampersand k. It means that p is pointing to the address of k. Okay, so k is what? K k is a variable which contains 10. Okay, so let us say that k's address is 4000. Let us say k's address is 4000, and p contains what? Address of k. So address of k is what? 4000. So that is 4000 here. So it so p is a pointer to an integer. So it means that p is pointing to this location because it is having the address. So it is p is a pointer, it is pointing to this location. Now print of percentage d star p star p. Star p means what? Value at this address. So value at 4000 is what? 10. So that will be printed. Okay. So this is how it works, right? Fine. So here is an example program. It's the same one. Let us see Let me execute this program and let me show to you. Okay, just a minute. So the program name is nano, sorry, ex1.c. That's the program name. So here you can see hash include stdio.h. This is used to, this is the header file which you should include for using printf and scanf statement, and every C program should start with this int main. Okay, here we are declaring two variables. One is integer a which is assigned with 10. And every C statement should end with a semicolon, and then another pointer integer star p. So p is a pointer to an integer, and then p is equal to address of a. So p is pointing to the address of a. Whatever the address of a, to that p is pointing. Now we are printing three things. What are they? Address stored in p is percentage %p. So p contains the address of a. Whatever the address of a, that is stored in p. So p will display the address of a. Okay. Value at location pointed by p is percentage %d slash n star p. Star p refers what? Value at location. So p is pointing to a's address. So what is the value at a's address? That is 10. So this will display 10. Okay, and the last one is the simple value of a is percentage %d slash n. That's the directly value of a, that is 10. Okay, and then return 0. Here we are using int main, so it should return with 0. If you are using void main, then you need not give return 0. Okay, so let me save this. Let me come out. Let me compile. So this is how you compile in Unix environment or Linux environment using GCC. GCC ex2.c-oex. So the program is compiled now. Execute dot slash ex2. Sorry, it's ex1. Okay, I'm sorry, it's ex1. That's ex1. Okay, so dot slash ex1. So you can see the address stored in p is, so this is the address. It's a very, so the address is a very big value. It's a, you can see it is represented in what you call, uh, it is represented in hexadecimal format, so that the f e all these things are appearing, and the value at location pointed by p is 10 and the value of a is 10. Okay, fine. So the next concept we will be discussing is there is something called as null pointer. So what is a null pointer? That, let me just brief it. So normally when you declare a pointer, it is advisable to declare pointer like this. See, int, whenever you declare a pointer, don't just declare int star p. Rather, you declare int star p is equal to null, which means that this pointer is currently not pointing anywhere. So to avoid such things, it is always advisable to make sure that the pointer is pointing to null. Okay. So now this pointer is pointing to null. So this is called as a null pointer. If a pointer is pointing to null, then such a pointer is called as null pointer. It means it is not pointing anywhere. That's it. So so this is an example of a null pointer. Okay, fine. So let me, and this null pointer we are just displaying. P points to address percentage p. Actually it is not pointing anywhere. So let us see what it gives the output. It is ex2. So let me execute ex2. It is telling p points to address nil. It is not pointing anywhere, right? So such a pointer which is not pointing to anywhere is called as a null pointer. So that is what is explained in this next slide. A null pointer is created by assigning null value. It is useful when you do not have any address assigned to the pointer. You have just created a pointer. You don't want to assign to any address at the time being. Then you just assign it to null. Okay, null pointer always contains the value 0, right? So this is how we display the null pointer. Okay. So here in this slide, you can see for address I am using percentage %x, but in the program I used percentage %p. The reason is in Linux environment you have to use percentage %p. In Windows or Unix environment you can use, for address you can use percentage %x or percentage %u. Okay, fine. So let us stop here for this lecture, and let us continue after this from the next class. Okay, so we have introduced, we have given a brief introduction to data structure, and also we have discussed a brief introduction to pointers. Fine. Thank you.